Hello and welcome to the interim presentation for Team 12 for Class ME 452 ISD 528. Our team has decided to perform an analysis and redesign of a planetary mechanical pencil sharpener. Our team members are Joy Allen, Connor Barash, Ariana Bressler, Alexandria Leone, and Patrick Okimi. The mechanical pencil sharpener is a tool that sharpens the writing point of wooden pencils, which is powered by a hand crank that rotates a cylindrical cutting apparatus in the sharpener. And for our mechanical pencil sharpener, our primary customers are teachers and students, while secondary customers are artists and office workers. Here's an exploded view of the original design, and this view allows our team to better understand how the sharpener functions.
Here is a fast diagram for the mechanical pencil sharpener. To sharpen the pencil, the sharpener removes material by ejecting shavings and cutting material. It also stabilizes the pencil by wedging the pencil and guiding insertions. To assure dependability, it prevents injury, prevents pencil breakage, and maintains stability. To enhance the product, it allows for portability. To please senses, it reduces noise. To assure convenience, it contains the shavings.
Here are two possible sequences for the assembly of the mechanical pencil sharpener. In it, there are two different sub-assemblies, one of which grips the pencil, while the other is used to sharpen the pencil.
This table compares the two previous assembly sequences based on the 5 criterion below. Assembly sequence 2 scored higher in the ease of locating parts category, as well as the ease of testing subassemblies, while the 2 sequences scored the same in the 3 other criterion, making sequence 2 the more desired assembly sequence.
The function component mapping matrix indicates how each part of the pencil sharpener contributes to the various functions. We can see that almost all parts have multiple functions.
Here we have the bill of materials and cost estimation for the pencil sharpener. The cost of each part has been calculated, and the total cost for all the parts and the assembly is $12.60. Here we have classified each part by their relative cost and functional importance. Based off of this, we decided to redesign the case, shaving tray, and outside cover, and eliminate the inside cover and backplate.
Primary customers for this product will be teachers and students who use the pencil sharpener frequently for cheap basic pencils and colored pencils, while secondary customers will be artists and office workers who will use the pencil sharpener for more personal use, for more specialty and high quality pencils and colored pencils. For our product family design, we have created a functional differentiation table. Here we are showing which functives are the same for both customer groups or different for each customer group from our fast diagram. Allowing portability, contain shavings, maintain stability, and provide adjustability are functives that are different for each customer group. From our functional differentiation table, we are able to figure out which modules we will have for our product family design. Modules will include the shavings tray and the crank handle.
The first part we decided to modify for our secondary customer group was a shavings tray. Because portability and ease of use is more important than the amount of shavings it holds and the price, we decided to slant the bottom of the tray in order to have less hard crevices to clean, and also have a cap that you can remove in order to dump the shavings without taking the tray out. The second part we decided to redesign for our secondary customer group was the handle. In order to make the sharpener more comfortable to use and more stable, we increased the length of the handle, which makes the part more expensive, but since the secondary customer group does not care much about price as they do about ease of use, we decided to make this change.
For the product family redesign, we showed the variances with the 2 assembly sequences. This slide shows the first sequence with the initial red nodes showing the steps that are shared between the multiple paths until they diverge. This slide shows an improved product family design sequence. In this, differentiation in assemblies changed slightly to prevent extra assembly steps needed in the four-way divergence and reduce assembly cost. Thank you for your time. Feel free to contact our design team if you have any questions.